Hello students, today we have to discuss about introduction of data mining. What is data mining? Data mining is the process of discovering interesting patterns and knowledge from large amount of data. So the data sources can include databases, data warehouses, the web, other information repositories or data that are streamed into the system dynamically. What kinds of data can be mined? Data mining can be applied to any kind of data as long as the data are meaningful for a target application. The most basic forms of data for mining applications are database data, data warehouse data, and transactional data. Data mining can also be applied to other forms of data. For example, data streams, ordered or sequence data, graph or networked data, spatial data, text data, multimedia data, and the World Wide Web data. First one is database data. A database system, also called a database management system, consists of a collection of interrelated data known as a database and a set of software programs to manage and access the data. The software programs provide mechanisms for defining database structures and data storage, for specifying and managing concurrent shared or distributed data access, for ensuring consistency and security of the information when system crashes or attempts at unauthorized access. A relational database is a collection of tables, each of which is assigned a unique name. Each table consists of a set of attributes, columns or fields and usually stores a large set of tuples that is called as records or rows. Each tuple in a relational table represents an object identified by a unique key and described by a set of attribute values. A semantic data model, such as an entity relationship data model, is constructed for relational databases. An ER data model represents the database as a set of entities and their relationships. Relational data can be accessed by database queries written in a relational query language, that is SQL, structured query language, or with the assistance of graphical user interfaces. A given query is transformed into a set of relational operations such as join, selection, and projection and is then optimized for efficient processing. A query allows retrieval of specified subsets of the data. Relational languages also use aggregate functions such as sum, average, count, maximum, and minimum. When mining relational databases, we can go further by searching for trends or data patterns. Data mining systems may also detect deviations, that is, items with sales that are far from those expected in comparison with the previous year data. So such deviations can then be further investigated. For example, data mining may discover that there has been a change in packaging of an item or a significant increase in price. Relational databases are one of the most commonly available and richest information repositories, and thus they are a major data form in the study of data mining. Next, we continue the types of data topic. So next one is data warehouses data. So a data warehouse is a depository of information collected from multiple sources, stored under a unified schema and usually residing at a single site. Data warehouses are constructed via a process of data cleaning, data integration, data transformation, data loading, and periodic data refreshing. For example, the following figure shows the typical framework for construction and the use of a data warehouse. So here we have to connected different data from different data sources and they are concatenated into a one repository that is called as data warehouse data. To facilitate decision making, the data in a data warehouse are organized around major subjects. For example, customer, item, supplier, and activity. So the data are stored to provide information from a historical perspective, such as in the past 6 to 12 months, and are typically summarized. For example, rather than storing the details of each sales transaction, the data warehouse may store a summary of the transactions per item type for each store or summarized to a higher level for each sales region. A data warehouse is usually modeled by a multi-dimensional data structure called a data cube, in which each dimension corresponds to an attribute or a set of attributes in the schema, and each cell stores the value of some aggregate measure such as count or sum. A data cube provides a multi-dimensional view of data and allows the pre-computation and fast access of summarized data. By providing multi-dimensional data views and the pre-computation of summarized data, data warehouse systems can provide inherent support for OLAP. So OLAP means online analytical processing operations that make use of background knowledge regarding the domain of the data being studied to allow the presentation of data at different levels of abstraction. Examples of OLAP operations include drill down and roll up, which allow the user to view the data at different degrees of summarization. So that will be illustrated in the following figure. So here drill down process is on sales data summarized by quarter to see data summarized by month. So similarly, roll up on sales data summarized by city to view data summarized by country. Data warehouse tools help support data analysis. Additional tools for data mining are often needed for in-depth analysis. Multidimensional data mining, it is also called as exploratory multidimensional data mining. It performs data mining in multidimensional space in an OLAP style. That is, it allows the exploration of multiple combinations of dimensions at varying levels of granularity in data mining, and it has greater potential for discovering interesting patterns representing knowledge. We continue the topic of types of data. So the next basic form of data is transactional data. Each record in a transactional database captures a transaction such as a customer's purchase, a flight booking, or a user's clicks on a web page. A transaction includes a unique transaction identity number, that is transaction ID, and a list of the items making up the transaction such as the items purchased in the transaction. A transactional database may have additional tables which contain other information related to the transactions such as item description, information about the salesperson or the branch, and so on. For example, given the knowledge that printers are commonly purchased together with computers, you could offer certain printers at a steep discount or even for free to the customers buying selected computers in the hopes of selling more computers, so which are often more expensive than printers. So data mining on transactional data can do so by mining frequent item sets, that is sets of items that are frequently sold together. So some other kinds of data will be available. So other kinds of data can be seen in many applications. So that is time related or sequence data. For example, historical records, stock exchange data, and time series and biological sequence data. Next one is data streams. For example, video surveillance and sensor data, which are continuously transmitted the information of data. So spatial data, for example, maps. The engineering design data, for example, the design of building system components or integrated circuits. Next one is hypertext and multimedia data. It including text, image, video, and audio data. So graph and network data, for example, social and information networks. And next one is web. So that is a huge, widely distributed information repository. It will available by the internet. These are all the other kinds of data. Thank you.